Now let's move on to section 3.4, because once you know how to find where the center is of data, which was 3.1, right, where's the center, and you know how to measure how spread out your data is, which is section 3.2, measures of disperse, right? And then 3.3 was just doing those two things again, but for more difficult data sets, i.e. grouped data, weighted means, that kind of thing. So the next thing you want to know is, where do individual values fall? And there are a lot of ways to measure this. We're going to do it in a couple of different ways. So let's think about this. Suppose you get a test back and you find that you got a 70%. How do you feel about your score? Well, in general, not too good, because I just barely passed, right? 70% is the cutoff for a 2.0, right? So it's not a great score, but you passed, so that's not bad, but it's a little bit shit. Now you find out that the mean on the test was 60, right? So you get your test back, you go, see, it's a 70, you go, meh. And then you say, hey, what was the exam average? That's the next thing you ask your teacher. And you find out it was 60. And now you're feeling much better, because then you know you did better than at least half the class, right? Because if half the class got, roughly half the class, got 60 or below, because that's the average. So you're thinking, hey, I'm not that bad. Now suppose I further tell you that the standard deviation on this exam was 10%. Okay, so see, you got a 70, take away a 60, you are 10% above the average, right? Which means you're one standard deviation above the average. So that's pretty good, right? Now, how do I know it's 1? Well, I can do it right here. So you take 70, take away the average of 60, divide it by 10. That's 10 over 10, which would be 1. Okay? But wait, what if it wasn't 10? What if it was 5? Okay, so instead of dividing it by 10, you divide it by 5. That would mean 10 over 5, which is 2. So now you're feeling really good, right? So that's awesome, because 2 standard deviations above the mean is unusually, I'll put it this way. Oh my goodness, I can't type. High. Right? So now you're feeling, hey, yeah, I only got a 70, but I was unusually high, right? Very high compared to the rest of the crew, right? The rest of the students in the class. So now that makes me feel better, right? If that makes sense. If you're in a competitive race, as it were, which of course classrooms aren't. Every student could get a 4 point if they wanted to, but me personally, I always feel a little bit better if I know I did better than most of the people in the class. That's just me. I guess I'm mean like that. Okay, so what we just did was we found z-scores. Z-scores are how far above or below the mean you are in terms of a number. So for example, the z-score for this one is 2, z equals 2. And this one is z equals 1. Now, these were both sample z-scores because we were dealing with a class, and a class will be a sample, not a population. If it was a population, then you do it that way too. And notice that z's are unitless. They have a mean of 0 and a standard deviation of 1. And we'll deal with that later. Now, suppose we have Steve, who is 6'4", and Alana, who's 5'9", and we want to know who is relatively taller. Now we know who is absolutely taller. Steve is, right? Because he's taller than Alana. So we want to find out how tall Steve is in terms of in relation to the rest of the group. Now Steve is 76 inches tall, minus the mean for guys. The mean for men is 69.2, divided by the standard deviation for men, which is 2.9. Oh, I'm out of time. All right. We will pick up right here next time for this.